Hello everyone, good to see you again. And today, in this video, I'm gonna demonstrate our second lab. Okay, so please, I believe you guys already downloaded the lab material and the answer sheet. And today in this lab, we don't have any data. So I believe all of you already read the uh, Blue Apron article, the Harvard Business Review article, and then so all of the information, we can find all of the information in the article. Okay, so we are gonna compute the lifetime value, customer lifetime value based on the information from the article. Okay, so that's what we are gonna do. So that's why we don't have any data set today. So please, so if you've not yet downloaded the lab material and the answer sheet, so please download them first. Okay, then this is our lab material. So the format is very similar to the previous lab material. So we have the overview. This explains what we are going to do in this lab. So in this lab, we will learn how to compute, how to calculate the individual customer lifetime value in Excel. Okay. All right. So one more thing. This is just a supplemental material to help the student understand the original case study, written by Daniel McCarthy and Eric Schwartz, 2018, entitled Blue Apron, Turning Around the Struggling Meal Kit Market Leader. This material does not contain any data, tables, and figures from the original case study due to the copyright. So sometimes you need to refer to the original article by the McCarthy and Schwartz. Okay, and I also uploaded another lecture to introduce what happened to the Blue Apron, this company. So this is a real company. This is a meal kit company. Maybe some of you already explained the service of the Blue Apron, maybe not. And then, so I believe you already watched another lecture video to introduce about the Blue Apron. Okay, so if you've not yet watched the video, please stop here. Please pause here for the lab, and then go back to that lecture. Maybe that is lecture 5, and then watch the lecture first, and then come back to the lab. Then just follow my directions here. Okay, so that's so if you've already watched the lecture, and then I think you are ready and I'm ready, then let's go. Okay, then so today we don't have any data set, so we need to open the Excel directly. So just open your Excel on your machine. So I just open my Excel here. Here. So, I have update. Just close it. And let me zoom. So maybe today 200% is the best, I think. Here we go. Okay. So today, we are gonna compute the lifetime value based on the information about the customers in the article. Okay. So to do that, first, let me just first talk about the equation, the lifetime value equation we are gonna compute. Okay. So you already watched my lecture about the lifetime value, not about the Blue Apron. So this is the slide maybe 29. And then, so this is the lifetime value equation. We are gonna compute this equation. Okay, so very complicated, but don't worry about it. I'm gonna explain the step by step how to compute this equation. And there's one more thing here. So just ignore the first equation here. So we are gonna use the second equation here and the third equation here. Okay, so we are gonna compute the lifetime value through these two different equations. Okay, this second line, the equation in the second line, and equation in the third line. And as you can see, it is equality mark. It means that both are the same as each other. Okay, so we are gonna actually test if they are actually the same as each other. Okay, so we are gonna compute this and compute this. And as you know very well, because you already watched my lecture, so in the lifetime value equation, we have four components. One, the gross contribution, GC, that is sometimes called margin, and in the article, this is called margin. And this is kind of a monthly salary, from the employee, perspective, like me. Okay, so I, earned a certain amount of money, from the Ohio State University every month, right? So like this. So this lifetime value equation means that the company gets some profit from a customer every month. So that amount of the profit from the customer every month, that is this gross contribution or the margin. Okay, and this is assumed that on average, this value is the same, and this does not change over time. Okay, on average, that is one assumption. Okay, just for simplicity, for analysis. And that's the first component. And the second component is the retention rate here. Okay, so we have the retention rate here. So not all customers just purchase the product every month. Some of the customers may leave the service, may leave the company, okay, after a certain amount of time, right? So we need to adjust the lifetime value by the probability of leaving or the probability of being retained. Okay, so this is that adjustment component. Okay, and here this retention rate. What is the definition of the retention rate? This is a kind of the monthly rate of the number of the people, number of the customers who still stay. Okay, so 1 month later, so let's just think about there's a certain time, and then now we want to compute the lifetime value as of this time. Okay, then so let's say this is a time 0. Okay, after 1 month or after one time period, then how many people can we expect, or what is the portion, the expected portion of the customers who still stay in our service, in our company? That is the retention rate itself, right? But after 2 months later or after 2 time period later, that probability or that rate is gonna be the retention rate times retention rate, the square of the retention rate. Okay, so after 3 months or after three time periods, then the portion, the proportion of the customers who still stay in our service, in our company, is gonna be cubic of the retention rate times retention rate times and retention rate. Okay, so that's why we have T here. Okay, so we are gonna multiply the retention rate T times after T time period. Okay, that's the rate of the number of the customers who still stay in our service. And there's one more component, okay, the third component, that is the acquisition cost. Okay, the cost incurred for acquiring the customer, right? So this is the third component. So, and this just affects just one time in the lifetime value. Okay, so we don't need to spend the acquisition cost for one customer once we acquired this customer, right? Once just we acquire this customer, and then we don't need to spend any money for the acquisition. Sometimes we need to spend money to reacquire the customer, but simply here, just assume that we are not gonna consider that kind of a situation, the reacquisition. Okay, so here we just simply think only we just need to acquire the customer just only once. Okay, so we just need to subtract this cost from our expected profit from the customers to compute the value of each customer. Okay, we just need to subtract this from the value just once. Okay, that's why this acquisition cost is outside of this summation. And the last component is the discount factor. Okay, so this adjusts the value of time. Okay, so as time goes by, the value of the money is going down and down and down and down and down. Okay, so we capture that adjusted value at the moment at the current moment, the current time period. So we need to consider this kind of the adjustment, for the value of time here. Okay. All right. So we have 4 components: the gross contribution, the retention rate, the acquisition cost, and the discount factor. Okay. And we have the numbers of those factors or those components, in the article. We are going to use those values to compute this complicated equation. Okay, that's our goal. And we are going to compute the same thing through the other equation. Still, we have 4 components here: gross contribution, the retention rate here, the acquisition cost here, and the discount factor here. Okay. Then now let's get started. To do that, so this is a kind of the blank Excel sheet. Okay, so please go back to our Excel. And the first step is to make the shape of the table for the computation. Okay, so just follow my direction. As I said, and as you know very well, we now have 4 components to compute the lifetime value for, that is margin or gross contribution. Okay, so just type margin here, and the retention rate. Okay, and then just let me increase the width to expand this row. Okay, and discount factor and acquisition cost. Oh, so we have these 4 components. Okay, so now we make the spaces or the rooms to store these 4 values. Okay, then additionally, just please make 2 more cells. So NPV simplified and LTV simply. These 2 cells is the lifetime value through this third equation. Okay, so we are going to compute the lifetime value through this third equation, and then the result will be placed in these 2 cells. Then here, one question: what is NPV? So we know what is LTV, but what is NPV? NPV is very simple. Okay, so in this equation or in this equation, we are gonna subtract the acquisition cost from the value of the customer, right? Here and here. Okay, NPV is the value before subtraction. Okay, so this highlighted part, that is the NPV. Okay, so net present value of a customer. And then first we are going to compute this NPV, and then we are going to subtract the acquisition cost from the NPV. Then that's the lifetime value, LTV. Okay, that's our step. That's our strategy. That's why we have these two cells here. All right. Then we need to make one more table, okay, to compute the lifetime value through the second equation. Okay. To do that, we need month, PV, NPV, and LTV. Maybe, yeah, in the article, the Blue Apron and the top managers consider the lifetime value and compute the lifetime value based on the monthly sales, the monthly margin, monthly gross contribution. Okay, so that is the time unit in the computation of lifetime value is every month. Here, this T indicates the month, each month. Okay, so we have a kind of a row or variable to store the month value, the first month and the second month and the third month and so on. Okay, we need to this month value to compute the lifetime value, compute the or the net present value. Okay, so that's why we make this. Oh, sorry. Yeah, it's fine. Okay, that's why we have this column here. And the second column is PV. This is different from NPV. What is this PV? Okay, this PV is that here you can see this summation mark. Okay, so first we are gonna compute what we are gonna add up. That is the terms, the mathematical terms inside of this summation. We first compute this part for each month. It means that for each value, and then after that we are gonna add up because we have the summation mark here. Okay, so this part, the value of this part for each month, that is the present value, PV. Okay, and then we are gonna accumulate this value for every month, and then that cumulative value is gonna be this summation. Okay, and that will be the NPV for every month. Okay, and then after that we are gonna subtract the acquisition cost from the value. Okay, and that is lifetime value. All right. So that's why we have this column PV, and we have NPV column here, and we have the lifetime value column here. All right. Then now let's put the month value first. If you read the article carefully, then you can remember and you can recall that the Blue Apron managers are considering the in total the 60 months to compute the lifetime value. All right, what does that mean? Here in the computation of the lifetime value, first we need to compute the projected value for each month. Okay, and then we are gonna this inside part this part inside the summation, and then we are gonna add up this from T is equal to 1, that is the first month, to infinity. What does that mean? We are gonna add some value again and again and again and again and again until T is equal to infinity. It means that we are gonna add again and again and again and again and again. So there is no limit. No worry. Even though we have the infinity terms to add, but here, if T goes to infinity, this retention rate term is going to 0, because retention rate, that is the percentage, that is the proportion, the rate, right? So that is smaller than 1 always, right? And when we multiply the value smaller than 1 again and again and again, and that value goes to 0. The same thing is here. 1 over 1 plus delta. This delta is always positive, so it means that this ratio, this fraction is always smaller than 1. Then we multiply this again and again and again, okay? Then this goes to 0, okay? So as time goes by, as t increases, then the part inside this summation goes to 0. Then when we add 0 to some certain value, it does not make any addition. It does not make any increment, right? Even though we just put very, very, very small, which is very close to 0 again and again and again and again and again, then the summation will be the same as before. It does not increase, okay? So that's why even though we have the infinite time here, we consider the infinite time, but the lifetime value converges to a certain finite value, okay? And one more thing. Because of that reason, okay, we don't need to compute the lifetime value for the infinite time period. Maybe we can just approximate enough length of the time, enough length of the time for the computation of the lifetime value. For example, as in the article, the time managers consider only the first 60 months. Okay, it means that we are not going to compute this infinite time horizon summation. We are going to compute the finite time summation from the first month to 60th month. That's what we are going to compute. Okay, so we are going to make the monthly value from 1 to 60. Okay, no more than 60. Okay, that's our goal. So to do that, let's place 1 here and 2 here. Then what's the next? 3. But it's very, very inefficient to just put all the numbers manually. Okay, so here is another Excel hack. Very simple. You already put these 2 numbers and then select these 2 cells, 1 and 2. Okay, with your shift button in your keyboard, or okay, you can just drag and drop. And then move your mouse cursor over this small button. Okay, and then this time we are gonna drag it down. Drag it down until the row 61 here. 61. Okay, then you can see all the numbers from 1 to 60 are put in these cells. Okay, very simple. That's it. Okay, and that's the month number. Okay, and then at this moment, just for safety, please save this Excel spreadsheet. Okay, so I'm gonna save. So file, save, Excel. Oh, where is my folder? Okay, just any folder is fine, but I want to save this in my files. All right, so here I'm gonna use Blue Apron. This is my name. So whatever, or you can use the Lab2. Whatever is fine. Just use any good file name here, and I'm gonna save here. All right, then let's start. In the article, you can find the numbers of these 4 components. Okay, so Blue Apron managers computed the average expected margin from each customer. That is about $26.8. Okay, that is on average, the average margin. And we're going to use this. And let's compute the lifetime value for just one segment model, one segment case. So in the article, there are two different analyses, right? One is the one segment model, and the other one is the two segment model. The one segment model just assumes that there's only one kind of customers there. Okay, so all of the customers are very similar to each other, and then for all of the customers, the analysis team just computed the average retention rate over time. That was 82.1%. Okay. So I'm using the percent the metric here, but you can use just sorry, this is the percentage. General. Yeah. You can just type like this fractional number. Okay. Otherwise fine. And the discount factor, just 1.53% of the discount factor is considered in this article. So that is 0.0153. Okay, so this is our discount factor. And acquisition cost in the article, the time managers assumed $100, okay, per customer to acquire each customer. Okay, so place this 100 here. Now we have these four components. Okay, and then now let's compute the present value for the first month first. Okay, that is for the first month, this t is equal to 1, right? So it means that this PV part, okay, the part inside this summation, that is equal to the retention rate times margin times 1 over 1 plus discount factor, because t is equal to 1 here. Okay, that's the present value for the first month. Okay, and what is the present value for the second month? Okay, in that case, t is equal to 2, so that is retention rate to the 2 times gross contribution times 1 over 1 plus delta to the 2. That's the PV for the second month. For the third month, t is equal to 3. That is retention rate to the 3 times gross contribution times 1 over 1 plus delta to the 3. So that's the PV for the third month. Then for the fourth month, t is equal to 4. Fifth month, t is equal to 5. Okay, so we can compute the each month present value very systematically. How? We just need to compute retention rate to the time value, where we have the time value here, 1, 2, 3 in column E. Okay, so we can use this column, the values in the column E for this T. Okay, and then we can make one equation for the present value for all time period. Okay, let's do that. So, okay, for your convenience, let me resize okay, fine. resized. Then let's compute the present value. Okay, so to do that, we need to start the equation in Excel. To do that, just place equality mark. Okay, and we have the first component here, the retention rate. Okay, and where's the retention rate? The retention rate is in the cell B2. Okay, so click this B2, and then we are going to multiply this B2 P times. Okay, that this exponent, can be expressed by head mark. The head mark, if you want to put the head mark, you need to press Shift and number 6 in your keyboard. So press Shift and number 6. Then you can see the head mark here. Okay, and then how many times the T? Where is the value of T? Where is the value of the time? That is in cell E2. Okay, so click E2. Okay, and then times. Okay, the times is the asterisk mark. Okay, in Excel. Okay, so place this asterisk mark. The next component is the gross contribution. That is margin. Okay, so where is the margin? The number of margin here is in B1. So click B1. Okay. Okay. And then times again. So place the asterisk mark again. And the next one is the discount factor term. Okay. And here we have the 1 over 1 plus delta. Okay. And they are in the parentheses, set of parentheses. Okay. So we just need to start the parentheses. Okay. Open the parentheses. So open the parentheses. And we have 1 here. So put 1 divided by 1 plus delta. Okay. So to express this fraction in Excel, we need one more set of the parentheses. Okay, so open the parentheses again, and 1. Now let's put the denominator. So 1, and here plus. What is the delta? Delta is the discount factor, which is in B3. So click this B3. Okay, and then close the parentheses. But be careful, we open the parentheses 2 times, okay, twice. So we need to close the parentheses twice. Okay, so close 1 and close 1 again. Okay, and then here to the T, we have one more exponent. That is the time value, which is in cell E2. Okay, but we need to put the hand mark, right? So press Shift and number 6. To put the hand mark here and click this discount factor cell again. The month cell again, E2. Okay. And then press enter. Then now you can get the present value for the first month. But now we just need to compute the same thing for the second month and the third month and so on. Okay. But these 4 values does not change over time. So it means that when we copy this equation into the other cell, all the cell number will be automatically adjusted, right? But the cell numbers which indicate these 4 numbers, okay, should not change. To do that, we need to put the dollar mark, okay? So click this F2 and then go to this, the formula bar, okay? And then place the dollar mark in front of B, before 2, okay? So B2, this does not change, okay? And E2, it should change over time, right? And how about the B1? That is the retention rate. It should not change, okay? So place the dollar mark in before B and before 1 again, okay? And how about the discount factor? It should not change, right? So this B3 also has the dollar mark before B and before 3, okay? Then press enter again. Then you can see the number does not change. But now we ready to copy this equation down to the 60th month. Okay, so to do that, you already learned the Excel hack. So move your mouse cursor over this small button, then you can find that, oh, the mouse cursor that changes from the white cross to this black cross, and then double click it. Then you can see the present value for each other month. Then let's scroll down. Okay, let's look at the number at the 60th month. Here, you may see very weird number format here. This means that, oh, this number is very, very small. This number is very, very close to 0. Anyway, as you can see, all the numbers decreases over time, as I told you. Okay, so this is just the increment for each month. We need to add up these numbers. We need to just accumulate these numbers over time, okay? And then this increment is very, very small, and it's getting lower and lower. It's getting smaller and smaller and smaller. And it means that the cumulative number will not change over time once this increment becomes very, very small. Okay, so let's test it. Okay, so how to accumulate those numbers? For the first month, the NPV, we just this means that the lifetime value, the net present value, considering only the first month, so that should be equal to the present value, right? Okay, so this should be equal to this F2. So place the equality mark here and click this F2 and just press enter. That is NPV up to the first month. How about the NPV up to the second month? That is NPV up to the first month plus the increment at the second month. So we just need to compute the sum of the NPV of the previous month and the PV of the current month. We just need to add these two values, okay? So here, just start the equation by put the equality mark and click this value, okay? And plus this value and press enter. Okay, and that is the NPV up to the second month. And now we just need to do the same thing for the remaining month. Okay, how to do that? Just move your mouse cursor over this small button and then just double click it. Then for the third month, this value is the sum of the number in G3 and number in F4, right? And that's the net present value up to the third month, right? So yeah, we get the correct number. Then just scroll down, then you can see as time goes by, the increment, the present value, is decreasing. It's getting smaller and smaller and smaller. And the accumulative value is just does not change not that much over time. So let's go down and just let's look at it. Around the 30th month, the NPV is now about 113, and after this month, the NPV value does not increase. Okay, just a little bit. Yeah? Let's look at the number before the decimal point. It just 113, 113, 113, 113 again and again and again and again and again. Okay, so last month, still the number before the decimal point is 113. So it means that around the 30th month, this NPV value becomes very flat. Okay, it does not increase, it does not decrease. It just stay around a certain number over time after the 30th month. Okay, then that means, oh, we can use this number as the approximation of the lifetime value for the infinite time period. Okay, we don't need to compute the net present value for just 100 time period, 100 months, 1000 months. Why? We don't need to do that. The increment is very, very small, so the value is not that different from this value. So we can approximate the lifetime value by using the lifetime value the lifetime value just considering only the first 60 months. Okay, and that's the PV. And what is the LTV, the lifetime value? We just need to subtract the acquisition cost from the NPV. Okay, so that means we just need to just start the equation by put the equality mark, and we just need to subtract the acquisition cost here from each NPV value. Okay, so click the NPV value minus the acquisition cost here, before. Okay, click before. Then you have this equation, but this before does not change over time, right? We just need to use the cell number before for all of the month, all of the time period. Okay, so that means we just need to put the dollar mark before V and before 4. Okay, and then press enter again. That's the lifetime value. Okay, and then just move your mouse cursor over this small button and double click it. Then you can get the lifetime value. Okay, and as you can see, the lifetime value here is negative. That's very natural, right? Why? We just consider only the first month. Okay, so we just get the the profit from the customer for only 1 month. Okay, so our profit from the customer is very small now, but we already spent the acquisition cost of the $100, so definitely the lifetime value should be small, should be negative. Okay, but over time, we don't need to spend any more money to acquire a customer, but once the customer is acquired, and then this customer just make the profit again and again and again every month. Okay, so every month, we can expect the profit. So this lifetime value increases as the time goes by. Okay, so you can see that this lifetime value is getting larger and larger and larger. And then after about 10 months, the lifetime value, changes from the negative value to the positive value. So now we can expect the profit. Okay, now we can expect the gain, after the 10th month from a customer. Then how about, so around the 30th month, okay, the expected lifetime value becomes $13, and over time this expected value from one customer does not that change. Okay, still 13 point something. Okay. So we can approximate this value as the lifetime value for the infinite time horizon. All right, so first, that's it. We already computed the net present value and the lifetime value through this second equation. Now, let's compute the same thing with the third equation, and then let's compare the result. All right, then just place this window here again. Okay, And so the net present value and the lifetime value based on from this equation, yeah, we have the answer here, where the NPV value and the LTV value at the 60th month, these two values. Okay, so this one is the NPV result. Okay, this is our lifetime value result. Okay, through this second equation. Okay, then now compute the same things through the third equation. Okay, and click here this B6 where we are gonna save the number of the NPV through this third equation, the simplified version. Okay, and just start the equation by pressing the equality mark here. And the first term is the gross contribution, that is the margin here. So click this B1 and times here. Okay, so press asterisk mark. Okay, and open a set of the parentheses. Okay, so open. And what is the numerator? Numerator is the retention rate. So click cell B2 divided by, so press the slash. And we need to put the denominator, and denominator has multiple terms, so we need to open another set of the parentheses. Okay, so open the parentheses again and press 1 minus retention rate again. So here click the retention rate again and plus the delta. Delta is the discount factor, so plus delta, and that's the all of the denominator. So just close the parentheses once and one more time, because we opened the parentheses 2 times here, right? And that's the NPV. So this is the NPV, okay, in the third equation. So this is the NPV. So just press enter. All right. And then what is the LTV? We just need to compute the LTV, we just need to subtract the acquisition cost from the NPV. Okay. So start the equation by pressing the equality mark and click NPV cell B6 minus acquisition cost and press enter. All right. And let's look at the number. Through the third equation, the NPV is about 113.2 and lifetime value is $13 and about $0.25, right? 13.25 or 24, something like that. And let's look at the NPV value and LTV value through the second equation. 113.24, very close, right? And 13.24, almost the same. Actually, this is almost exactly the same, right? So we can compute the lifetime value through this second equation, and we can compute the lifetime value through the third equation. Whatever is fine. But the third equation, which is much simpler, right? So it would be better to compute the lifetime value through the third equation, right? And in general, and in practice, most researchers and the most analysts are using the third equation to compute the lifetime value, because this is simple, but this is powerful to capture all kind of the variation, okay, or all kind of the environmental factor, all kind of the changes in the market and the company, okay, and customers. All right. So here we just do the lifetime value computation. Then let's go to our answer sheet. And let's look at the first question. Question number 1. You may find the present value becomes 0. That means that almost 0, and NPV and LTV become flat over time. Which month? As I told you, around the 30th month. Okay. So Yeah, it could be 29th, it could be 31, yeah, whatever is fine, okay? Around the 30th month. Yeah, that's my thought. And complete the following statement. Because the PV of a customer is discounted by, so here, just be careful, PV, present value, okay? It means that we need to focus on the part inside the summation, okay? That is, we need to think about only these three terms: retention rate, the gross contribution, and the discount factor, okay? Here, what makes this term discounted? As I told you, the retention rate and the discount factor. Because they are smaller than 1, and this fraction is smaller than 1, and when we multiply those terms again and again and again several times, and then the value is getting smaller and smaller and smaller, and finally goes to 0. That is the discounting the value of this entire part, right? So that is, this PV is discounted by retention rate and discount factor. Okay, so that's the structure. You need to understand, clearly understand the structure of the present value and the net present value and the lifetime value. So this is technically, this is very important. Okay. All right. And question 3. Calculate the simplified NPV and LTV in cells B6 and B7. We already computed the NPV and LTV, simplified version, here and here. Okay, so these two numbers. In my experience, some of the students asked about the rounding. Okay, any rounding is fine. If you want to round up the number at the first decimal point, it's fine. Second decimal point, it's fine. Okay, so 113.24, it's good. 113.2, it's also fine. Okay, so just use your the best one for the rounding. Okay, to answer this question. Okay. So we already computed the NPV and LTV. And then, now let's move on to the next part. Again, there are two different sets of the analysis. The one is that the one segment model where only one type of a customer is assumed. Okay, and the second model, the second analysis is called the two segment model, where two different types of the customers assumed. One is the high loyalty customer, and the two is low loyalty customer. What's the difference between these two types or the two segments? That is the retention rate. Okay, the high loyalty segment, their retention rate is 92.3%. You can find this number in the article. Okay, so replace it for the retention rate in cell B2. Okay, so here 0.821, we need to replace 0.923 for this cell. Okay, and press enter. Then this is the magic. Okay, we are using Excel, and we just change the retention rate, and then all the computation, all the numbers, will be automatically changed, automatically computed again. Okay, so with the new retention rate, the net present value becomes $268, and the lifetime value becomes $168. Yeah, that's the answer to question number 4. Question number 5. The low loyalty segment, their retention rate is 43.4%. What we have to do, we just need to replace this number with 43.4%. Okay, so just replace 434 and enter. you can see the net present value is just $20. Then definitely the lifetime value becomes negative, about negative $80. So with this very low retention rate for the low loyalty customer, then we can expect loss instead of gain from each customer, the low loyalty customer. Okay, that's the very important. Then let's go to the question number 6. And yeah, you need to just carefully memorize this lifetime value with this very small retention rate for the low loyalty customer. And in our discussion session, maybe in the next week, so we are gonna discuss about several strategies, to enhance the lifetime value and the customer equity, for the Blue Apron. And to develop the strategies, you must carefully, think about this negative value of the lifetime value for the low loyalty customers. Okay. All right. Then let's move on to the question number 6. High loyalty segment and the proportion of this type of customers is about 46. This high loyalty, 46%, and low loyalty segment takes about the others, 54%. Then the question number 6 is compute the average net present value and the lifetime value for all the customers in these two segments. Okay, that average, because the proportion of the segment is different from each other, is different between these two segments. So we need to think about this weighted average. We cannot compute the simple average. Okay. So I'm gonna explain this weighted average only for the lifetime value here, and then you can apply the same strategy for the weighted average for the net present value. Okay. So for the low loyalty customer, the lifetime value was LTV was negative $80. Okay, and the high loyalty customers, the LTV, what was that? 923. Okay, so let's compute again. And the lifetime value was $168. Okay, we have these two numbers, and we are going to compute the weighted average of these two numbers. So here, the high loyalty segment, this segment takes 46%, and low loyalty takes 54%. And how to compute the weighted average? Here's a hint. Okay, just think about that. There are 100 customers, and out of them, because the proportion of the high loyalty segment is 46%, it means that out of 100 customers, only 46 customers are high loyal customers, and the others 54 customers are low loyal customers. Okay, so out of 100 customers, just think about there are 100 customers, 46 customers, okay, their LTV is 168, okay, 168, and the others, 54 customers, okay, their lifetime value is negative $80, okay, negative $80. And this amount is the sum of the lifetime value for all of the customers. And we have 100 customers. So to compute the average, we just need to divide this number by the total number of the customers. That is 100. Okay? So, just for your... And to avoid the confusion, just place the parentheses here again. This is the equation of the weighted average. Okay, assume that there are 100 customers, and then compute the average of those 100 customers. Okay, and 46%, that is the proportion of the high loyal segment, and 54%, that is the proportion of the low loyal segment. Okay, then this becomes the average of those 100 customers, and that is equal to the weighted average of all of the customers. Okay, then yeah, this is the weighted average of LTV. Okay, then you can use the same strategy to compute the weighted average of NPV. Okay, yeah, I'm gonna leave this for you. Okay? And that's it. Yeah, that's all we have, okay, in this lab. Okay, so yeah, please complete all the questions of the lab, and then don't forget, you need to submit your answer sheet as well as your Excel file. So you need to submit these two files. Okay. All right. If you have any question, or if you have any problems during this lab, just don't hesitate to contact me to make an appointment for the one-on-one meeting through the Zoom. Okay, and then have a wonderful week, and see you on the next Tuesday. Yeah, for the discussion. Yeah, for the Blue Apron, the case. All right. Bye bye.